All right, so we are live. Hello, everyone, and this is the first episode of Web Mentor webinars. So, a lot of you were asking me what exactly is Web Mentor webinars. So, I feel that yes, it's lockdown going on, and there are a lot of online courses, lot of online lectures. But the thing is, one thing which we lack is the feel of one-on-one interaction and interacting with people who can actually help us. So I thought of an idea where I can bring to you a few highly experienced people in domains like blockchain, development, design, and so on, and they will present some content with you, and then you can have some interaction with them so that you can learn more. So here's the first episode of Web Mentor Webinar Initiative, and I hope you are as excited as I am. So yes, handing over the mic to Arpita. And before that, yes, I would like to thank the four co-organizers for this initiative: Arpita, Bharti, Khushbu, and Sakshi. You all are doing a very great job, and thanks a lot for volunteering to organize this initiative. That's really great. And yes, let's get started without making our audience wait. So I hope you all are as excited as I am.
Hello everyone, I am Arpita, one of the co-organizers of Web Mentor webinar series. I welcome you all to the first episode of Web Mentor webinars. Today we have our special guest Abhitej, who is co-founder at Cosmos India. Cosmos India is a non-profit organization which aims to foster the growth of blockchain technology in India. I personally believe that blockchain is something which could change the world more than the people can imagine. Today, Abhitej will be talking about what blockchain and crypto are, how we can get started with them, followed by Q&A. I am super excited for this session. So let's get started. Hi, Abhitej. Welcome on board. We are grateful to have you here today.
Absolutely, equally thrilled, Arpita, to be here. And thank you so much, guys, for taking over for this session. I hope that everyone um, good session around this and have plenty and plenty of questions, and so that I can also learn and get new perspective from people. So, yes, as you say, we're ready to get started.
Yeah.
So, um, So I'll quickly start with an introduction. Hey guys, I'm Abhitej Singh, and I graduated from VIT University in 2019. And pretty much in my last year, I got connected to people who were already working in blockchain space, and they showed me the vision of what has happened in last decade and what's going to happen in next 10 years in the blockchain space. And pretty much I like the very concept of blockchain in a way that it's going to revolutionize the way we think or we use the internet today. So if you see that there is this cycle of innovation after every 20 years. So back in 1960s when computer first came into play, and then after 20 years we started seeing some sort of personal computers came into picture, and then everyone had a computer on their desk. And 20 years later we jumped into the dot-com era where internet was taking up, people could access data, though they were static websites, but you could now book things right from your house. So the ease of things happened. And in the last 20 years we have seen people going to fetch anything physically. Now they can get almost anything at their home, at the ease of their home, just with a click of a button. So the immense potential that internet has provided us in terms of accessing data, connecting with people, accessibility to a lot of things that were not possible for, say, our parents or their parents. So in the next evolution that was supposed to happen was around privacy, was around to happen where authority, that is monopoly that comes in play, and sometimes you just receive what you are supposed to receive and not what you deserve to receive. That's why when 2008 crash came to US, there was huge about how the banking sector was operating, and then Satoshi Nakamoto, which is an anonymous organization or individual, came up with this beautiful idea of how finance, or how at least currency, could be changed and could be the power could be provided to the community's hand, and that is how Bitcoin was took birth in 2008. And in this 10 years adopting it has seen it's not just a medium of transferring amount from one place to another. It's an expression to show that, okay, or explore the ways how different things are possible. So I quickly wanted to show you guys a slide that had a little bit trouble with accessing. I'll just try again. To show you like what is the goal. Yeah, while we see. So what happened then is, in these 10 years, when people started realizing how much potential this decentralized network had.
I think there was there's some issue. So I'm so sorry for this. Just give me a minute, so we'll resolve it. So, are you sharing your screen? Okay, so just try to speak something like, is it? I'll let you know that you're audible or not.
Hello, am I audible?
Yes, yes, you are. Okay, so I'll go back again. I think there was some network issue or something.
Yeah, I just wanted to switch to my laptop. So yeah, so in this possibility, what happens is that any technology, when it's new, there's a lot of speculation around that technology. There are things that people try to do, and that's what happened in last 10 years. People were exploring this decentralized network. They were trying to see what sort of potential it has. We saw Bitcoin. After Bitcoin, we saw Ethereum come into play, and after that, we saw Cosmos or Polkadot coming into play. So these are all different protocols at different times serving different things. So in this session, we'll kindly quickly sort of see what happens and why there is a requirement. What are the basics of blockchain? So that's why I wanted to not throw jargons and give you very simple examples. So a lot of people ask me like the why blockchain is so different from when people say, okay, we are building applications on blockchain, and then when we have a conversation, it pretty much boils down to they're building something on Hyperledger or R3 Corda. And then what happens is that there is a difference between a blockchain and a DLT, and that is what we'll try to cover in this session as well. That a lot of people don't understand what actually blockchain is. They see it as a blockchain and crypto as two different units, which is not true. So, so if you have to kind of understand the role of both together, then it's generally blockchain is an engine and crypto is the fuel. So if you have to understand that, okay, how an engine won't work without fuel, right? Similar way, blockchain cannot work without crypto. Trying to share my screen.
Yes, you can just press share screen button, and then you should be able to.
Sure. Um, just giving a couple of permissions.
So in the meantime, guys, you guys can just keep on asking your questions, and we can keep interacting so that so even before the webinar, I got a lot of questions in the form, Google form, which we circulated, and there was one very interesting question which I got. It was, uh, can blockchain technology be integrated with IoT technologies? What do you think, Abhitej, on this particular thing?
Absolutely. I mean, IoT is one of the things which, I'll tell you the latest stage that you're accessing a huge amount of data, and this data can be manipulated in multiple ways, which kind of gives you false results later on. People can manipulate it to show variety of things. That's why blockchain plays a very important role in terms of providing immutability, and that this data which is being accessed by multiple devices is not manipulated. And there's a very interesting use case in the logistics department, where logistics or supply chain management, where you could see a source of any product, and the source, how it's been transported over time in trucks. So it was the product kept in proper temperature, and so then all the stakeholders in the ecosystem kind of have to abide by a proper norm, so that they will have to, they can't manipulate data. So if something was not certainly kept in a temperature it should have been while transporting, then and then you could see at blockchain, okay, this product may expire much before than it should supposed to be, because it wasn't kept by the logistics company in a proper temperature. Similar way, if some stock, Walmart did it beautifully, I would say. So they could, rather than what happens right now in a lot of places, is that, say, something comes to you, a stock comes to you, and this stock, a certain stock out of a complete consignment goes bad. Maybe it's mangoes or guava or anything. Then Walmart or any big organization have to dump the entire consignment rather than a small portion of stock, which could have gone bad for a number of reasons. But this, with this integration of IoT and blockchain together, you could actually track back the entire history of that product, from where it came, in what temperatures it was kept, in what sort of circumstances it was grown. Maybe sometimes what happens is something isn't supposed to be grown in a certain soil or certain region, and then they have less durability in terms of their growth. Or sort of environment they should have got, they didn't get. So in this way you could see that, and then you could track back, and rather than dumping the entire consignment, you could just see from this source to which endpoints the products went, and then you could just dump those products. So it's a lot of economical for a lot of people to use this. This is one just of example. So yeah, I guess I'm good to share my screen. Are you able to see my screen now?
Yes. So we'll just add it to the stream. Just give us a second. Yeah, you can open now. It's on the stream. You can open the slides. All right, guys. So now it's going to be super exciting, and let's get started. So I'll go
Yeah.
on mute now. All right.
Yeah, sure. So, hey guys, now it's when we start this session. So, what we need to understand first is that what exactly blockchain is and why it is there is such a huge hype about blockchain. So, this is a presentation which we generally use in a lot of our sessions to talk about blockchain, and a lot of it is curated by one of the other co-founders who is also the CEO of Persistence, Tushar. A lot of great ideas in here, so I'm sure you guys will enjoy it. So the thing is with that any technology which is a foundational technology has a lot of potential, has have had potential over the ages. So blockchain is also a foundational technology, and how does that seem? So first we need to understand what a foundational technology is. Any technology that the end consumer doesn't need to know what's happening in the background. And then second thing is that a lot of other things can be built on top of it. For example, which we generally take as the first foundational technology humankind knows about is fire. And so you to use fire, you don't have to understand what sort of chemical reactions are going on in the background, right? If that was the case, every time you would go to cook Maggie, it would have been such a challenging task if you would have to know what sort of chemical reactions are happening in the background. So um, so that's why you at top of fire you could build n number of technologies. So on top of fire we built electricity, and electricity also served as a foundational technology, and over electricity we built PCs, and over PCs we built internet. So now in internet you don't need to know what sort of how data is being transmitted from one place to another, what sort of servers are being used in background. You just go and type google.com and you could see XYZ website, or you could see whatever data you want, research papers, images, videos, anything, right? Similar way over internet, the other thing that took birth over internet was smartphones, and smartphones have made our life tremendously easy. Now, um, what anyone needs to do is just a click away. So if you got to book a cab, you could just press book a cab, and cab would come to your doorstep. So if you understand that smartphones themselves are a foundational technology, to call an Uber, you don't need to know what's happening in the background, how the request is being sent from your mobile phone to the driver, what sort of algorithms are being used. All you have to do is click the first button. So you don't need to know what's happening in the background. Similar way, there are the three technologies that are taking place in the current time, and they all have huge potential. So first one is of course blockchain. Other technologies are AI, ML, big data, and somebody asked this interesting question: IoT. All of these are also foundational technologies. Now, interesting case is over blockchain you could build n number of things. Now people have started to build over blockchain finance protocol, so you could relate it to so that's called decentralized finance. You could lend, you could borrow things. People have started to build auditable trails over blockchain, that everything is stored in a form of a record on top of blockchain. So in terms of like this is very important to understand that why a technology which is a foundational technology has a lot of scope. So if you take example, other technologies that exist, maybe it's like front-end technologies, we are using back-end technologies of being a part of the bigger internet. But blockchain and all other technologies that we see as the last on the top step are themselves sort of a whole world of possibilities, and blockchain tends to revolutionize how we see internet. So I'll give you a very simple analogy which I use generally to, or I used it to understand blockchain myself. So let's take an example now when we start to guess what a blockchain is. As Madhav mentioned, and I have had listened a lot of people use this, which is partly true that blockchain is like a ledger or it's record of like blocks, a network of blocks. So each block has a certain set of records that that are connected with each other, and they're immutable. So that is a very kind of um, still I kind of say a low level understanding. A lot of people get confused that okay, how the data is stored on a block, because actually you're not storing the entire data. You're storing timestamps, you're storing the hash, or like a key value associated to one particular record or data. So let's understand with this example, and please, after this, we'll kind of open up to questions so that it's not a one-way communication. I understand if you guys are able to make sense what I'm saying. So take an example of you are in there is a classroom, and in a classroom there are 100 students. Now each student is a sort of related to a node. Okay, all these students are sitting, and then there is one teacher. Our teacher is where we will be using as a network. So kind of teacher is a network, and all of these students in a classroom are nodes. So what happens is this is a classroom which is not a general classroom. You enter this classroom for the first time, and you don't know any student in this class. So what happens is that a teacher says you, hello everyone, you have to write each student's name in this classroom in your notebook. So what happens is that you all write the names of students. Now the interesting part here is that each student can write the names in their own sequence. There is no particular sequence like Madhav, Abhitej, Arpita, Hitesh. There's no particular sequence. It could be I could write Madhav first, somebody could write Arpita first. So it's like everybody is writing in their own manner, but all of them are writing these 100 names. So at the once everybody has written 100 names, teacher says that okay, provide a value of 10 against all these names. So there is like everyone has sort of 10 rupees, if I would say okay, 10 rupees in their account. And this 10 rupees, now everyone has it. So all of them have 100 names in their notebook. All of them have like every name has a value 10. So everyone has a similar data. Now this data is what we call, when we reach this state, is called genesis state. So what genesis state is the state from where any blockchain kind of evolves or starts. So it's like Bitcoin had its genesis state back in 2008 when the first um, Bitcoin was started to be mined. So before that mining, so before the Bitcoin could actually take off, everyone, all these nodes, which like I'm taking example of students, came to this genesis state where everyone has a similar record, similar sort of data with them. Now, over how this data evolves is how the blockchain will evolve. So now, if uh, maybe Arpita or Madhav, if you can tell me, ask a question on the chat. Am I making sense? So if people are able to understand this example, if not, then maybe I could take another example.
Definitely, we'll ask. And I think it was a pretty good example. Uh, I think I understood everything. So I think
No,
most of them.
yeah,
So
sure.
yes,
So if we proceed with this same example, so what happens now is I have been always a naughty kid, or not say naughty, but I've been always a curious kid. have been always super hyper. So what happens is now teacher has said, okay, everyone has 100 names, everyone has 10 rupees in their account. Now I stand up and say, okay, I want to send 10 rupees to Madhav. Okay. Now, what teacher says is, okay, this is a request that the teacher, here in the blockchain terms, it is the network which has received. So what teacher says is, teacher asks all the students that, okay, we will vote if Abhitej has 10 rupees in his account or against his name. So once like everybody opens their notebook, everybody sees where they have written 100 names. So now all of them start voting yes and no. So since it's the first example, let's say I have 10 rupees, right? So everybody started voting yes, 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 yes. And once like a majority is reached, for example, the majority or the consensus state for Bitcoin network is 51%. So out of these 100 students, 51 students have to agree or say yes that I have 10 rupees in my account. Now, once these 51 students have said yes, then we call is we reach at a consensus. Now consensus is a simple English word which is like agreement among different parties is what is consensus. So here I'll take example of like how it works in blockchain or crypto world, but here let's see that everybody reached in 51 students reached an agreement that Abhitej has 10 rupees. So what network allows is to send this 10 rupees to Madhav. So what they everyone has to do in their notebook now, teacher says everyone write down that Abhitej has 0 and Madhav has 10 plus 10. So Madhav has 10 plus 10 rupees. And actually I'm not saying this 20 for a certain reason. It's like 10 plus 10 now. So Madhav has 10 rupees. Now, what happens is over this discussion and meeting with people, I could figure out like, okay, these four people are, they speak English. So let's take an example of how we can connect with others. So I started to believe that I can convince them, these four people. I went to them, I talked to them, and I said, hey guys, you know what? We you all you need to do is I again want to send 10 rupees, but I don't have 10 rupees. What we can do is that you guys could support me and say yes, I have 10 rupees, and then what will happen is I'll give a small part of that to you if that transaction goes through. So I could convince 4, 5, or 6 students, right? So there's this small section of students or in this classroom who are together now, who have um, who trying to create a malicious transaction. So when teacher, I stand up again and I say, okay, I want to send 10 rupees to Madhav again. So now teacher says, okay, this is a request that we have received, and teacher tells all students, please open your notebooks and see if Abhitej has 10 rupees and he could send it to Madhav. So everyone sees their notebooks, and then teachers again starts voting. Now what happens is that each student starts to vote, but like everyone says no, 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 and in a certain that when it reaches to me and my 6 friends, everyone says yes, yes, yes. Okay, so what happens is that these 6 people have kind of trying to create a malicious activity. But these friends were those people who kind of loved sports or any one reason I could connect with them, right? So, but not everybody liked sports in the classroom. I didn't know everybody in the classroom. So what happens is this transaction fails because 51 students said no, and this transaction didn't go through. So this is kind of an very high level view of how transaction happens, and what this students are a P2P network. They are a peer-to-peer network. So all are sort of nodes. Now the interesting part is here: what happens in a traditional um, system? So like why blockchain is different. If I was a bank, I had the I had the right or authority over all the nodes that were running in in a network, and that's how we see all the scams happening. Um, Nirav Modi or say XYZ, Vijay Malia, there are n number of examples. None of them had money, but banks still approved their loans. Banks still provided them liquidity. They allowed them to do business. And then these guys went rogue, and then the money, who lost money? Money was lost by the normal people, the like common people like me and you, right? So why that happened? Because in a central authority, they have all nodes running by a same authority, so they could collude together and they could do these malicious transactions. But that is not possible in a blockchain, because you don't know all these nodes that are part of this network. Second, there is higher incentive for the people to do the right thing, and that is part second of people to understand why blockchain works how it works. Now this
I have a
incentive,
question here. Like,
yeah,
can I ask? So
yeah.
basically, it seems to be very, very good, but still there are many, many sort of places where we see 51% attacks. So why do these things happen? Because we aren't even aware of the people who are there on the chain, right? So how is that possible that 51% attacks take place?
Yeah, so how it happens is it is important that how decentralized your network is. So if you take an example, a network which is just starting up. So take an example how it happens. Taking the same example that was what I tried to do is I'll not use any jargons in this, at least in this session. So what happens is take same example of classroom. Now, what happens is a network was started and the teacher invited 40 students from VIT, and then 10 students from, or say 20 students from SRM, 20 students from BITS Pilani, and 10 students from different IITs, right? So now all of these students are there. So I kind of somewhere know 40 students in this classroom because they are from VIT. And then I had some friend who has come from BITS Pilani. He has some friends who he knows, right? So what happens is this whole P2P network or these nodes, whatever we say, take an example, these students don't come from different, a very decentralized network. The example I was using earlier was where you could see students from Africa, students from Asia, Europe, Australia, and I didn't know them. So now here I have this advantage. I kind of know some. So it's not decentralized. The network is not very decentralized, right? You have these big players, VIT and some certificates. So when like earlier I was trying to collude, I had to convince each person individually because I didn't know them at all. But here I know kind of 40 people. I know a friend from VIT, BITS Pilani. I knew a friend from SRM. I knew a friend from IIT Bombay. And all I had to do is convince these other 11 people out of my network. So you are able to create a 51% attack in networks which are not very decentralized. Networks which are trying to run a blockchain, but they are not very decentralized. They don't have nodes across the world. They don't have nodes running by multiple individuals. And
Mhm.
so, if you take an example, Bitcoin as a network has never been completely hacked. Okay? There have
Yeah.
been attempts. There have been certain sort of um, activity that was pushed in, but was quickly recovered from. So if you see why that happens, but because Bitcoin is very decentralized. People run nodes on Bitcoin network from across the world. So taking example, this is a Bitcoin class. No student, no other student, each other, right?
Yeah.
And take an example of X network, which had a 51% attack. Now here, certain entities or certain individuals nodes know each other. So that is, if that answers your question.
Yeah. So, so I think to reach that level of decentralization, how feasible is it for any new blockchain? Like, let's say a new crypto comes in the market. So, how feasible is it for that particular? Because at the start, it needs support. So, how will people support it at the beginning? Because I think in the beginning, it's most vulnerable to these kinds of attacks.
Yeah, so that is an interesting part, and actually, I think a lot of people will get confused if I say it. So before you kind of jump into the main net, where you are doing the real transactions, or where high value transactions are going through, like how Bitcoin, Ethereum, or Cosmos operates today, the thing is that before that you have multiple stages, just like you would build a website, right? You don't push your website the first iteration you do right away onto web, right? You don't do that. If you do so, there would be n number of vulnerabilities. So there would be endpoints, which can be hacked, or which could be accessed easily, and then the entire website could be took down, or it could be taken down. Now, similar way happens with a blockchain. Before a blockchain goes into a mainnet, there are a series of test nets or series of internal node distribution. So they kind of different networks. Every network tries to involve a lot of different stakeholders. And these stakeholders then sort of keep growing and growing over different, say, testnet 1 or testnet beta, alpha, um, whatever nomenclature you use. And before you kind of jump into a mainnet, you have certain people who are supporting your network. So there is enough decentralization to go out there and start using your network.
I see. That was interesting. So now I have asked enough questions. Do you want to
Yeah.
continue, or should we take one or two questions from the audience first? I see a few
I
interesting
mean,
questions.
I just want to take one quick and the train of thought I had about the crypto part, where incentivization and de-incentivization I was telling about, and then we can open up to questions so that people
Yes.
understand at least the basics.
Yep. Definitely. Yeah.
So,
I'll just share the screen again. Yeah.
yes, if you could please. Um, so, in this simple way, I was telling you about, again, how the now these six people who colluded me back when I did a wrong transaction. Teacher kind of got teacher, who is the network, got knew that these people were trying to do a malicious transaction. So what happens in a general classroom when you do something which is not widely accepted, or something that is malicious, notorious in that example? Teacher throws you out of the class or gives you punishment if you're in school. So this punishment is sort of a de-incentivization, or sort of a punishment to do wrong. And I have had multiple such sort of punishments in my school, right? When I would do something mischievous, my teacher would throw me out of the class and ask me to raise my hands. Now, how does that incentivization and de-incentivization works? So these six people who colluded were thrown out of the class, so they have a disincentive. And the teacher said, whoever did the right thing would be awarded 1 marks. each one an additional marks, brownie point, as teachers like to call it. So this is an incentive for each person to do the right thing. Now, the normal in blockchain world, how it happens is that these incentives are like in place, and the disincentives are pretty much higher. So it's in the benefit of people to do the right thing, and that incentive and disincentive is provided by crypto. So this is where I said that, if blockchain is the engine, then crypto is the is a fuel. So in this case, these all people were sort of provided some sort of crypto. So Marx, as we can take an example, is like a crypto. Now, the people who were sent out of the class got -5 marks, and these -5 marks were sort of distributed among all these other nodes which did the right thing as an incentive. So plus 1 marks for each node. So I just want to come to the screen. Stop sharing my screen. Yeah. So this is what happens in a general blockchain. So there's crypto and there is blockchain. Crypto is a form of ensuring that there is enough incentive for people to do the right thing. Now, if you ask me, what if I don't have a crypto in my network? What if all these nodes are working without an incentive? Then this is the difference. That is a DLT. That DLT is called distributed ledger technology. So what we are trying to do is kind of creating a public ledger which is accessible by everyone, and that is also like sort of the foundation for blockchain. But since blockchain has this incentivization de-incentivization model, it makes it different from DLT. So if anyone asks you what is the major difference between DLT and blockchain, the the first thing you could tell them is that DLT lacks incentivization and de-incentivization model. So a lot of people can still go and do malicious activities in a DLT technology, or a DLT, distributed ledger technology. Example of distributed ledger technologies, if you ask me, there's Hyperledger, of course. A lot of people develop smart contracts on Hyperledger. There's R3 Corda. There is Quorum. So a lot of these are also known as private blockchains, um, but at a high level, they are DLTs. So if this kind of gives you a broad view, there's a couple of things in the session that wanted to cover in depth. Like I'll give more example. And so there's one interesting example I take. I said you a word. They reached to a consensus. Now, what is a consensus? Like how it works. So there's this funny example which I have developed, and this might not be 100% right, but kind of gives idea of how things work. So we all sort of live in a family, right? So take an example. There's a joint family, a large family, and this family, I am the youngest one. So being a youngest one, I want a cycle, right? So a bicycle. And over me, there are multiple people who kind of are making decisions. So, right, if you're the youngest one, you would know the pain. You have an elder brother, elder sister, mother, father, grandmother, grandfather, uncle, aunt, so many people. And each one has this voting power in each decision you make in your life. So, for example, here it's bicycle. So what happens is, I say I need a bicycle. My mom goes and tells it to everybody that, okay, Abhitej wants a bicycle. And what happens is, my grandfather says, okay, he should get a bicycle. But my grandmother says, no, he shouldn't. He breaks everything. My elder brother, elder sister, of course, like all. every sibling, they were like, no, he shouldn't get a bicycle. He doesn't study, he doesn't obey us, things like that. And then somehow, majority of the family reaches an agreement. So say 51% of these people say, no, Abhitej is not going to get a bicycle. So my mom says, okay, the matter is closed and Abhitej is not going to get a bicycle. But my dad is soft hearted and he realizes that he has worked hard, got okay marks. So he says, I will go secretly get him a bicycle, and then nobody would kind of
Your voice is breaking a little bit. I guess it's the network issue once again. Can you reconnect or maybe something like that? Mm, all right. I guess there was some network issue. Yeah, I'm so sorry for that. Uh, yes,
Am I
he's
back?
back. All right.
Yeah.
Great.
I'm sorry. Just still in trouble. So what happens is my mom gets really angry, and then what she does is she. So what happens in journey houses? What sort of de-incentivization happens? My mom gets angry. Everybody gets angry. And my mom is like, "You're gonna sleep on the sofa or the couch for the next 5 days, or you're not gonna get all the favorite food you want to eat." So but that is de-incentivized for doing something which he wasn't supposed to do once the consensus was reached. So this is how interesting it is. Nobody could, once the network has reached a certain decision about any transaction, and this transaction is not essentially money or transfer of an asset. It could be anything. I want to access a platform XYZ and I send a request. That is a transaction. I want to start a new account. That is a transaction. On blockchain, each thing is considered as a transaction. Now, this is how we have understood what P2P network is at the base, which are different nodes. We have understood in like very high level what consensus is, where agreement happens and how that happens. So everyone has to agree, and majority if agrees on something, that's a consensus there. Now all of that is happening. My request for bicycle, um, my request for say something, sending the transaction to Madhav, all of that at the top is an application. Okay, so it's an application that sits on top of consensus and the P2P layer. So these three layers together is what is blockchain. And to make sure that the consensus happens in a very unbiased and proper manner, there is this incentive that is or de-incentive that is provided by crypto. And crypto is this form of getting people into a network where they have economic skin, like skin in the game. That's an economic incentive or de-incentive. Now, if every time I did a good thing in a class, I got good marks or like a bonus marks, and every time I did a wrong thing, I got negative marks, like -5. For every good thing, +1. For every wrong thing, -5. What each one of you would do? Would you go or agree to be that guy who goes to zero or even like negative of that? Or you would want to earn some sort of bonus marks that boosts up your performance, right? So in normal human behavior, everyone wants that +1 marks. So that's kind of very high level what crypto and blockchain is. And open to a lot of questions now you guys can ask, and based on that we could take the conversation forward.
That was really helpful, especially the example. It was very creative. And we have some questions in the chat box. I'll bring it here for you.
Sure.
So, Abhishek asked, do you believe changing encryption algorithms in blockchain will help in increasing the data transfer speed through it?
So, this encryption algorithms are certainly a way to hash data, or sort of um, privatize your data so that not everything is accessible to people, right? So if like you want to see address sent, what sort of like how much tokens where, but you don't want people to know, okay, Abhitej sent money to mother, or and these nodes which are doing these transactions shouldn't know that Abhitej or certain address is sending money to this address. If they know this address, then they could turn biased. So the encryption algorithms are much to do with the privacy and the security of the network, but the data transfer speed, or this actually not exactly data transfer, but the verification or validation of these transactions that are happening on the network can be increased with in multiple ways. Now, if you have to understand is there are different consensus models. So we talked about these consensus models, right? Consensus. So there is proof of work. So there's Bitcoin that operates on proof of work, and I understand where Abhishek is coming from. Abhishek is understands that there is a lot of transactions are very slow on Ethereum or blockchain, right? So why has to do a redundant work. Each node has to do this redundant work to do solve the same problem. Now, what happens is if there are so many transactions that come in a network at a certain time, then all these transactions sort of start piling up, and until one transaction is completely solved, the other transaction is not solved. The other transaction is not solved. So take an example. This is an interesting concept, and I wanted to discuss it some at some place in this webinar. But so let me give you this example. Think of a term where you are sitting in a classroom, and a math teacher comes, and a math teacher provides you a problem, a mathematical problem. Now, what happens is each student is trying to solve one problem at a time. And until you don't get solve this one problem, say at least one student in a class doesn't solve this problem, the teacher doesn't give you the second problem. So take example, there are 10 problems. Each student is taking 5 minutes. Say each problem is almost taking 5 minutes to solve the entire question set. You would need 50 minutes. If we take on general, it is taking 5 minutes. Then what happens is the system is slow. Now, if teacher says, okay, I'm going to give you 20 questions, then it is going to take more time for students to solve this. So how this can be solved is the speed of transaction. So how this can be solved is improving the consensus model, which all approve a transaction. So this solution for it came in a form of change of the consensus model, which, for example, like Cosmos follows is a DPoS, or a proof of stake model. What we talked earlier was proof of work, where every student was trying to solve the same problem. And if one student reached the solution, then
Um,
I think
I
his voice is breaking again.
yeah, yeah, yeah. It's some network issue. Can you try to reconnect your hotspot, or maybe I'm not sure whether he can hear us. Uh, um, mm, mm. Let's wait for 2 more minutes. Ideally, he should be able to join back. So for the time
Yeah,
being,
sure.
you guys can fill up the small uh, feedback form. Yeah. Just wait for 1 or 2 minutes, guys. I've pinged him. Should be able to join in a few more minutes. Oh, he's here. Awesome.
I'm sorry about that, guys. So yeah, change the position so it's better. Um, so what happens is that now other way around, which improves the speed as you ask the question, is using something like proof of stake. Now, what happens in a proof of stake is that rather than each one solving this problem, teacher kind of picks 10 people in the classroom, and these 10 people are kind of, say you get to pick these 10 people, and you say, okay, class topper who has been getting um, full out of full marks in maths, you're going to pick one of that. You're going to pick, okay, who's second, who's third, somebody who's kind of smart or is popular. You picked one of your, one is very guy who kind of everyone likes but don't know much about it, so you pick these 10 people. Now what you're trying to do is, you say, teacher asks that these 10 students are going to solve the problem, and each student behind them can, it's kind of, you could bet on a certain person, like who is going to solve this problem. So what happens is, now rather than everybody solving this problem, 50, like all the students solving these problems, teacher gives a certain all these 10 problems together, and then these students are try they are able to kind of solve it much faster, because now certain people are trying to pick a certain problem and then solve it. So this is some sort of how POS network solves, where rather than everybody solving the same problem, they kind of pick a problem, and then um, they could reach to consensus quicker. So earlier, like, one student solved a problem, and each student, everyone had to sort of, now all 50 students needed to agree to that solution. Here you come quickly with the solution, and 10 students who are trying to solve come to a consensus, okay, if this is right or not, and then you could quickly solve it. So where it was taking 50 minutes earlier to solve 10 problems, here you could solve it as less as like 10 minutes or even 5 minutes. If that answers your question, how it happens. This is how you could improve the speed of the network, not by exactly by encryption algorithms.
Okay, so we have next question. What is actual meaning of block in blockchain?
Okay, this is an interesting question. So block is a, so what happens is that a certain transactions are, so there is like transaction one, two, three, four. These certain transactions are taken. There is time frame. There is a certain period in which these transactions are happening and getting improved. These certain transactions are put together. So the hash values of all these transactions are put together, and these are stored onto a chain, the network basically. The chain is the network, which is approved by all the transactions. So these this set of transactions which are stored in a particular time frame is what a block is. So if that answers your question. So each network has a different block time. So on Bitcoin, you could have a block time, say, much larger. On the new networks like Cosmos, the block time is pretty less. So blocks are mined very fast, where you kind of reach 1 million blocks in Bitcoin over like 3 to 4 or 5 years, whatever it could be. That could be reached pretty faster on a platform like Cosmos, right? So because the block time is faster, because transactions are getting approved faster. So this is what a block is.
Okay, that was quite helpful. So we have next question related to the previous one only. What is block time?
Okay, yeah, interesting. So block time is the time taken to mine or like storing a certain amount of transactions on blockchain is what block time is. So how much time it takes for whatever the minimum value is to be verified and put onto chain is what a block time is.
Okay, so we have the next question. What, according to you, is the biggest misconception about blockchain?
Biggest misconception about blockchain is that blockchain is good and crypto is bad. A lot of people sort of believe that crypto is bad. It's about volatility. It's only about investment. If you invest in Bitcoin, then you can earn a lot of money, and then it may go to zero as well. But it's not true. Crypto and blockchain are not different. I told you, if there is no, so that like this is the unit. If we remove the crypto part of it, then it's not a blockchain, it's a DLT. Only once this crypto is plugged in together is when you understand, okay, this whole system together is blockchain. So this is the biggest misconception.
Okay.
Other second one is, which is more on the popular belief, is that it's too late to get into blockchain or crypto, which is, I would say, we are still not getting started. Like we're not still getting it. We have got started with blockchain exactly. We are in very early days. Taking example of internet, we are in kind of 1996 when internet was just starting up. You could just get a static website on internet. That's where we are today in blockchain. So it's not late. You could start today and make tons and tons of innovations and new discoveries in the space.
So we have the next question by Harsh. Should fresher get started in blockchain technology or learn web or app development first?
I believe you could get started not as a just as a fresher, but you could start in your school as well. I have one of people who are associated to the Cosmos India Ambassador program. He started with blockchain when he was in class 10th. So, and you don't need to exactly learn front end technologies or web development to get started with blockchain. You could be a simple you just need to have a simple understanding of how coding works. If you know that, you're good enough to start with blockchain, and there are tremendous amount of resources that are available to learn how to get started with blockchain.
I hope that answers his question. So the next question we have here is, what can be the small and getting started projects for the one who is beginner in the blockchain?
What can be the small and getting starting projects? So somebody, if is just getting started in blockchain, you could try to first spin up a node on any network, say Ethereum or Bitcoin. So sort of what it gives you an idea is how to participate in a network. And if you're already sort of you don't want to spin up a node, then there are pretty much interesting cases that you could go and experiment with the existing projects. So you could go out, look for how to build a dApp on Ethereum. For example, you could have just a small function. So there are two entities. One is a small example I'm giving. You guys could try out is that in a college there's students, and each student is sort of sending this word to the other person. So that like it's like, how do you get somebody to stand on their word? So if how in generally happens is that you say something to someone, and then that guy is after 5 days says, hey, I didn't say that, that didn't happen. So you can make a very simple application where you kind of type on your mobile phone, and you said, okay, I said this, and the other person kind of can receive a notification that this person said this, and that is stored onto any chain of your preference, and that sort of kind of stores that value, and anybody can go back and look at, okay, what somebody said at a certain time frame, what sort of transaction happened at a certain time. That this is an use case. This is an interesting use case. You guys could try that, how to store what person said on a certain time. If this is also difficult, you could just store about values of what you did at a certain time, so that it is not manipulated. So if you are, there's one thing is that a lot of time happens is you submit your assignment, but it doesn't get submitted. So this is an interesting use case a lot of students can propose to their colleges. Is what happens is if you submit assignment, it doesn't go to the teacher, and teacher says, I'm going to get your 20 marks because you didn't submit your assignment. But if that was on blockchain, and say you have 20 nodes, which involves teachers, students, everybody, and all of these nodes kind of came in on consensus. Now you don't exactly need crypto for this, but say you have this virtual token, which is like, which gets you, for example, we have this food place in VIT called Enzo, or so you could go and receive some sort of uh, cold drink or something from Enzo. So you could have that token to give away some sort of, there would be like at the end of the day, who has the most tokens will sort of be awarded with the most active person. It could be any gamification you do. So what happens is student submits assignment, the network can come to a consensus if the assignment went through or not. And if like the assignment is submitted, then the teacher cannot come back to you and say, I didn't receive the assignment, that is went through. And if the assignment is not submitted, the student cannot say the assignment was submitted, but due to some technical issues it didn't go through. So this is an interesting simple application you could build.
Okay, that was really good idea. So we have our next question from Maramirdi. Can you say in what way these digital medium is way more useful than monetary transaction through banks?
Um, this is a very good question, and I appreciate Madam Reddy asking this question. So, ma'am, what happens is that in a bank, when you do a transaction, bank is the sole owner of seeing through that data. So you might send a transaction from here to somebody, but what happened is it didn't go through. But then the bank says, it happens with a lot of people at a lot of times, that they send a transaction, say I was booking a ticket on Paytm. Now the money was directed from my bank, but it didn't reach Paytm. So Paytm didn't approve my ticket. What happens is they keep on bouncing from each other, that we have sent the money to Paytm, and Paytm says they haven't received the money will go back. And this is a very small sort of thing where banks sort of fail. But the other interesting case is taking an example of 2008 financial crisis, where banks were trying to create some sort of, they were giving away loans without validating people, and sort of people's money was lended out. Now, when the crash came in, none of these big entities, these banks, kind of got um, they weren't affected much, right? They came back, they bounced back. Who lost their money? The normal people lost their money. So you don't know if the bank exactly going belly up because you don't have transparency. And the very recent example of that is Yes Bank. So Yes Bank kind of collapsed and people lost their money because you didn't have the visibility of what bank is doing. So these digital mediums provide you three things. First one is they provide you auditability. Second one is they provide you transparency. And third and final thing is that it provides you immutability. Now, a bank cannot go back and say, okay, the certain person did give money or not give money. So they cannot change it. If the network sort of agrees on something that somebody has money and they sent it or they didn't send it, then it is stored there. So, as an authority, as a bank, if that is running on a decentralized or blockchain, I cannot go back and change it. So, a lot of a lot of banks do it, and you could go out and look at interesting case studies, interesting documentaries about how banks change their books, how banks manipulate the data before um, sort of going for an audit or something or through audits. And that is why these digital mediums are much better than banks because everyone in the network has the visibility of what's happening. And there can be never a transaction like if you would know where a transaction went, at what time, and to what address.
Absolutely, absolutely. Transparency is something which is like very, very much higher in blockchains. So
Absolutely.
I hope that answers her question. So we have the last question for today, and it is: does data structure techniques like hashing and some other services as a frame for blockchain? Does
Uh,
data structure techniques like hashing and some other serves as a framework for blockchain? I think it's framework.
Yeah, so suddenly what happens is that there are layers. So I told you, like, when you start off, of course, there's an encryption model before a transaction goes to a network. So if I am proposing something, I'm doing a transaction. So what happens are there are these hashing algorithms which sort of receive these transactions, and once they have to go through this hashing algorithms, they are changed into a hash. So they are just alphanumeric. It's an alphanumeric term or a collection of alphanumeric characters. And this alphanumeric transaction numeric words are sent to the nodes. And these nodes try to solve um, they solve an hash problem which kind of is associated with this particular encrypted data. And that is how that transaction goes through or not. So yes, of course, it's a medium of making the network secure. And the first thing is how a transaction goes to the network. So before getting a network, there is this layer where these algorithms are used. So it's a sort of a wall between your network and your like a private or like my interaction, your application and the network. This goes through this. Yeah. So it's not exactly the frame, but it's a medium between the network and the end user.
Okay, so we had like so many questions, and we would love if you would ping Abhitej on LinkedIn or on Twitter. He would love to answer your questions. So thank you so much, Abhitej. That was really an insightful session for all of us, and we are so happy that you could join us today and gave us a perspective toward the blockchain and crypto world. And I'd like to thank all the audience for their presence and patience. And please do fill out the feedback forms. And I would like to thank to all the Web Mentor webinar team for making this event a great success. So keep learning, keep sharing, And thank you all. Bye.
Yeah, just want to
Cheers.
add one thing.
Yeah, yeah, sure, please.
Arpita, if you allow me. So
Yeah,
you
yeah,
guys,
please.
this was a session which I really appreciate Web Mentor team as well as Madhav for taking this initiative to reach out and say, hey guys, we can do this. It was a very basic and elementary session where I didn't want to get too much deep, but please feel free, as Arpita mentioned, to ping me on Twitter or on LinkedIn. You could also join the Cosmos India community on Telegram. You just need to go out and say type Cosmos India, and then you could interact with all the team members of Cosmos India. There are developers, there are traders. Cosmos, it's not Cosmos, but Cosmos India. So if you have to see, so this is like the spelling of Cosmos India. So this Cosmos, you could go out and look at what Cosmos is trying to do. So we talked about the Bitcoin and how the network works, but a lot of things have changed over years. And I give you a quick example of how proof of stake networks work. Cosmos is a proof of stake network, and in case you guys are, you want to learn more, please feel free to drop your questions on the Telegram chat we have or interact with our Twitter page. Pretty active about different opportunities on Twitter. You could just go and search for Cosmos India underscore. So that's our Twitter handle. And we have these various programs we do continuously. Like there is Cosmos India Ambassador program. You could, if you are very eager to learn about blockchain and you want to learn about Cosmos Network, and then you want to relay that information to your local community, you could join our Cosmos India Ambassador program, where we kind of train you, teach you about how you could utilize blockchain, what sort of how to build on Cosmos, and then you could go out and relay this information to your local community. And then we have series of webinars like this itself. We keep on doing with multiple people, so you could learn more every one time we try to touch on a new subject. And we have these bounties as well, so we plan to keep doing some sort of bounties. So if you're trying, you're just starting out, so you don't need to be a blockchain developer exactly to get hold of all these bounties. And this is what I want to, before I wanted to go out, wanted to encourage everybody that if you are a web developer, I've mentioned it earlier also, that there are tremendous sort of like opportunities out there, like numerous opportunities. The UX part of blockchain is still way behind the curve. So it's very difficult. The usability is difficult. So you have all these technical terms, numbers bouncing on blockchain applications. So if you're a front end developer, you're a UI UX designer, then you have a huge um, sort of ocean of possibilities that you could come in and say you could try to make the application more usable. And if you're a DevOps engineer, if you're a DevOps enthusiast, you could go out and work on the security of the network. So you could try participate in different hackathons, different test nets. As I said, there's incentivized test nets to try to bring down the network. So you have to hack different nodes. So you get bounties or you get prizes in return of doing that. So there's a number of things you could do. You guys are interested in finance. You could work on, you could work on crypto side of things. You could work on tokenomics. If you're a marketing guy, then of course you could work out like me and spread word about blockchain with with the community as well as other stakeholders. So yeah, again, thank you so much, guys, for listening me, and I hope I could make a little sense out of this session. And happy to take any follow-up questions on the links Madhav shared.
Thank you so much, Abhitej, for sharing like so many opportunities, and we would definitely love to be the part of those. And we'll be back next weekend with another session, which would be mind blowing as it was. So thank you all for tuning in today. Thank you, Abhitej, once again.
Bye bye, guys. Thank you so much. Have
Bye,
fun.
Abhitej.